Imagine your smart factory where machines talk to the cloud, sensors send real time data, and dashboards update instantly. But what actually connects all these systems together? The answer is API, Application Programming Interface. An API is basically a bridge that allows different software systems to communicate with each other. APIs allow one system to request data or services from another system without needing to know how it works internally. Now, why is this important in IIoT? IIoT is all about connecting industrial machines, sensors, and control systems to the internet so that data can be collected, analyzed, and used to make smarter decisions. But here's the challenge: these devices are often made by different manufacturers, use different protocols, and generate different types of data. This is where APIs become critical. APIs act as a standardized interface that allows all these different components to talk to each other seamlessly. For example, a temperature sensor on a factory floor can send data to a cloud platform using an API. That cloud platform can then process the data and expose it through another API to a dashboard application used by engineers or managers. Most modern IIoT systems use REST APIs. REST stands for Representational State Transfer. These APIs use HTTP methods like GET, POST, PUT, and DELETE. For example, a GET request might retrieve sensor data, while a POST request might send new data to a server. The data is usually formatted in JSON, which is lightweight and easy to parse. So, if you've worked with web development or backend systems, you'll notice the same concepts being applied in industrial environments. Now, let's connect this to real world applications. Imagine a smart factory. Machines are equipped with sensors that continuously monitor parameters like temperature, vibration, and pressure. These sensors send data via APIs to a centralized system. That system analyzes the data and detects anomalies. If a machine shows unusual vibration patterns, an API can trigger an alert system or even integrate with a maintenance platform to automatically schedule repairs. This is called predictive maintenance, and it's one of the most powerful use cases of IIoT. Another example is energy management. Industrial plants consume huge amounts of energy. APIs can collect data from smart meters and feed it into analytics platforms. Engineers can then optimize energy usage, reduce costs, and improve sustainability. You'll also see APIs playing a key role in connecting IIoT systems with cloud platforms like AWS IoT, Azure IoT Hub, or Google Cloud IoT. These platforms provide APIs to ingest data, run analytics, and even deploy machine learning models. While APIs define how applications interact, protocols like MQTT, HTTP, and CoAP define how data is transmitted. MQTT, in particular, is widely used in IoT because it's lightweight and efficient for devices with limited resources. So, in a typical IoT architecture, you might have devices communicating via MQTT, data being processed in the cloud, and APIs exposing that data to applications. It connects your knowledge of programming, networking, and embedded systems into one practical framework. To sum it up, APIs are the backbone of IIoT systems. If you focus on learning how APIs work, along with protocols like MQTT and tools like cloud IoT platforms, you'll be well prepared to work on real industrial systems.